Alright guys, so for this video we are going to continue section 4.1. Last time we ended right here where I asked you to complete this on your own. And guys, you need to show me your work, okay? So make sure all the work is there. Now if you did your work, hopefully your answer was f of x equals x to the third minus 2x plus 4, okay? Even though I'm giving you the answer here, but make sure your work is shown prior to that. Now we're going to continue with example 4. Example 4 has 4 different parts here. So first one, I want you to list each 0 and its multiplicity. The second one, I want you to determine whether the graph touches or crosses at each 0. Step 3, determine the max number of turning points. And step 4, determine the end behavior. Okay. So we're going to start with this very first one. A, f of x equals 4 times x plus 4 times the quantity. And it looks like I'm missing a plus sign right here. So can you do me a favor and just write x plus 3 to the power of 3? Again, typo. So, and then with that, okay? So part 1i. Part 1i says list each 0 and its multiplicity. So each 0 meaning that you take your equation, okay, and you set it equal to 0. And that's all that is. So when I take my equation, and here we go, set it equal to 0, I have 0 equals 4 times x plus 4 times x plus 3 to the third power. Okay. Now, so technically, you can take each one and set it equal to 0. Well, 0 equals 4. That would never make sense, right? If I take this and set it equals to 0 and take this, well, x to the third, meaning that I have 3 of these, okay? I don't need to write 3 of those identical ones, so I'm just going to use 1 and write equals 0. So here are my zeros. X equals to negative 4, x equals to negative 3. So the zeros are, okay, negative 4, and it says, and tell me the multiplicity. Well, this 0 only has 1 power, right? There's only one negative 4 out there, so we can say multiplicity of 1. Well, notice how this x plus 3 to the third power, even though there's 1 0, x equals negative 3, but it has a multiplicity of 3. Because if I need to write this out, technically there are 3 of these, right? So, but because they're exactly the same 0, so we only write it one time. But we can say, hey, there has a multiple of 3. I mean, there's 3 of these out there. So that's 1i. 2i, it says determine whether the graph touches or crosses at each 0. If you recall, if even multiplicity will touch, right? So let's remind ourselves. Even multiplicity, meaning touches, okay, x-axis. And then odd multiplicity, that means we are going to cross. So crosses the x-axis. Okay. So this is just from your definition or vocabulary. So let's look at the first one. It says determine whether the graph touches or crosses at each 0. So 2i at x equals negative 4, because I have a multiplicity of 1, it crosses. Okay. Then another one I have x equals negative 3. It has an odd multiplicity as well because it has a multiplicity of 3, so it also crosses. Okay. So since these are both odd multiplicity, they're both going to cross over the at the x-axis at negative 4 and negative 3. Okay. Next, 3i says determine the max number of turning points. So let's 3i's. Okay. Max number of turning points, remember how it's 1 less than the degree, even though this one doesn't ask for the degree. So let's look at the degree of this one. Okay. Okay. This one has a degree of 3. This one has a degree of 4. So degree of f of x is if I were to multiply this all out, okay, if I were to FOIL this all out, the term with the highest degree would have to be degree of 4. Because when you're multiplying numbers, you add the power. This is a power of 1, this is a power of 3. When I add them, I have a degree of 4. Okay? So degree of f of x is 4. It didn't ask for it, but I'm going to need to use it to answer 3i. The max number of turning points would be 1 less than the degree of the function. Since the degree of the function is 4, I will have at most 3 turning points. Okay. 4i. So let's go. Here we go. 4i's, notice how it says determine the end behavior. Well, the end behavior is also the power function, and is going to be, start out with f of x equals. You would need f of x equals, alright? Well, if I were to multiply this out, so let's talk about if I were to multiply this out, I only need to worry about the first term, okay, of each factor. So I would have 4 times x is 4x. 4x times x to the third power is going to be 4x to the fourth power, because I would need to add my exponents. So this is 4x to the fourth power. So pretty much the end behavior, okay, or the power function, is if you were to multiply this all out, which you don't have to, you just have to look at the very first thing, okay? What would be the highest, what would be the term with the highest x power? So that's what that is. All right? Okay, let's move on to this one. F of x equals x plus square root of 3 to the power of 2 times the quantity of x minus 2 to the square of 4. So, we're going to talk about 1i. Find the zeros, okay? So the zeros is meaning that I'm going to set each factor equal to 0. If I take this factor and I set it equal to 0, okay, with the power 2, meaning I can do it twice, or I can just later write multiplicity of 2. So that's my first 0, and x minus 2 equals to 0. So when I solve for x equals a negative square root of 2, and x equals a positive 2. I can write this out twice, and I can write this out 4 times, but the direction says, hey, find the zeros and tell me the multiplicity. So the zeros are negative 2, multiplicity of 2, okay? Then this one over here, at 2, we have a multiplicity of 4. Okay? So that's how we list it out, or that's how we answer this question. 2i's says determine whether the graph touches or crosses at each one. Well, because they both have even multiplicity, so at negative square root of 2, okay, is going to touch or touches the x-axis. At 4, it will also touch, or the function will touch or touches the x-axis. So it's really up to you how you want to write that out. 3i's determine the max number of turning points. So 1, 2, 3, okay. Okay, remember the max turning point is going to be 1 less than the degree. Okay, so let's look at the degree of this. Okay, so degree. The degree is pretty much, if I were to FOIL this out, okay, what would be the largest power? So let's take this, okay. This is x times x, but this one has x squared, so x squared times x to the 4th. When you multiply, you add the exponent, so that's really degree of 6. Okay, so degree is 6. So when you're looking at the turning points, you're gonna have 1 less. So at most 5 turning points. It's always 1 less than the degree. Then we have 4i's. Oops, I wrote I and then 4. I meant an I and a V. Okay. 4i says determine the end behavior. Alright. So in this one, we actually do have to multiply it out. So for part A, notice how I took the 4 and then the x here. So pretty much the first of every factor. Well, this one has a 1 in the front, so I don't need to worry about that. So x to the second times x to the fourth. The end behavior, it's an equation, so we'd write f of x equals x to the 6th. And I'm just going to take a break to drink some water. Okay. And please just listen to it again if you didn't get any or some of the parts here. Now we're moving on to example 5. Construct a polynomial for the given. Okay. Well, this one, it's kind of the same thing. Let me move on. Let me flip back to this example. Okay. Construct and form a polynomial is exactly the same thing. I'm asking you to write an equation of a polynomial. That's all I'm asking. Over here, though, you were giving the zeros. So you just have to put them together and then FOIL it out. Over here, you are given a graph. Okay. But it looks like a 0 is given to you as well. So let's look it up. So do we know the zeros right away? Okay. The zeros are, looks like the first one's -6, and then we have a -3, then we have a +3, and we have a 4. And these are just numbers I made up, so they might not be accurate at all. Alright, so we have 4 zeros. See those right there? Okay. We're now going to put them together with 4 sets of parentheses. 1, 2, 3, and 4. Okay. And because we are given a graph, we're going to find the leading coefficient as well. The reason, let me bring you back to this. The reason that we didn't find the leading coefficients here because we weren't given any other information except the zeros. So we assume the leading coefficient is 1. Okay? But over here, we cannot assume the leading coefficient is 1 because it's obvious that there are other stuff going on. There's 2 other points that's given to us. So let's start with x minus. Okay. My first 0 is -6. My next one is -3. And this one's a +3 and a +4. Okay. Then we can definitely make this into positive here and positive here. So from here, we would like to, you don't need to FOIL this out, and I'm going to give you a reason why you don't need to FOIL it out. On the test, okay, on the test, if you have a degree of 4 or higher, you can just leave them as factor form like these, because it's just, I'm just trying to save you time. So once you have written down like this, you don't have to FOIL it out, but you do have to find your A. Now, find A, okay? Once you find A, we would need to use another point that have not been used. So I can't use the zeros again, but I can use either this point or that point. It's up to you. You can decide whatever point you want to use. Now, because keep in mind, I made up these points, so they might not be as accurate, okay? So now, what I want to use is the easy one, the one with a 0 in it, okay? So I'm going to start with when x is 0, y is 3. So this is y, so I'm going to let that be 3. And A is what I'm trying to find, so I'm going to keep A as A. So every time I see an x, I'm going to put in 0. So 0 plus 6 times 0 plus 3 times 0 minus 3 and times 0 minus 4. Okay? Well, 0 times, and 0 add or plus or subtract anything, it's itself, so we can just now multiply. So we have 3 times 6, that's going to be 18. Let's bust out my friendly calculator just to see just to see if I can do the math right. So 18 times -3. So here we go. 18 times -3, -54, then times -4. So currently we have a positive 216. Okay. So 3 equals positive 216 times A. Then again, we're still trying to find A, so we're gonna divide both sides by 216. Okay, looks like this is going to be reducible, so let's reduce it. We're going to divide the top and bottom by 3. Okay, so 3 divided by 3 is going to give me 1, so a equals 1. And 21 divided by 3 is 7. 6 divided by 3 is 2, so 1 over 72. That's my a value. So now let's write the final equation so we can box it up. F of x equals a, which is, now I know what it is, 1 over 72. Okay, so 1 over 72 times quantity of x plus 6 times quantity of x plus 3 times quantity x minus 3 times quantity x minus 4. And this is my boxed up answer. Okay, now because you are listening, I'm going to remind you, if you have a power of 4 or higher, like 4 or 5 or 6, you do not need to multiply these out. You can leave these in factor form. It's going to save you so much time. Now, if you are not listening, and you're just copying down the notes without listening, and if you're taking the time to multiply these out in your test, then it is your fault because you did not listen. So you're going to waste all like 20 minutes trying to multiply this out and not finish the quiz. Then it's all going to be your fault. So if you're listening, this is a benefit to us, okay? Okay, let's move on to our next example. Well, actually, since we have a check for understanding, why don't you spend the time and do the check for understanding for me, okay? So this is going to be on your own. Okay, spend the next couple minutes to do the check for you. Again, if you have 4 or more zeros, you don't have to multiply it out. But looks like you have 1, 2, 3, 3 zeros here, so you will have to multiply it out. So if you have 3, 2 zeros, then you need to multiply out your factors. If you have 4 or more, then you can just, I'm going to try to save you some time by not having you multiply it out. Alright, so this is the end of the video notes. I will continue with the last example on the next one. Have a wonderful day.